morning. It is time for our math lesson for Monday, May 11th. Today we are going to be talking about how you can display measurement data in a line plot. We're going to be using pages 743 to 746 in My Math. I want to start by teaching you the words measurement data and line plot. So here I have a word problem, and it says, this table shows the distance some children rode a bicycle. Draw a line plot to represent the data. So here in this table, we have some information. The information is measurements of the distances that some children rode a bicycle. So this here is measurement data. Data means information. So we have this measurement information, this measurement data, and it's asking us to represent it on a line plot. A line plot means a number line where you draw X's above each space to show how many times that measurement is used. So let me give you an example. So here in this data, I have 6 children went 1/5 of a mile. 4 children rode 2/5 of a mile. 2 children rode 3/5 of a mile. 2 children rode 4/5 of a mile, and 1 child rode 1 mile. So what I'm going to do is I'm going to draw a number line. Actually, I want to give myself a little more space. So I'm going to draw it a little bit lower because I'm going to need to make X's above it. So I do not want my, my X's to run into the top where the words are. So I mark my number line from 0 to 1 because my largest measurement is 1 whole mile. So I'm going to go 0 to 1. And then my measurements are all measured in 1/5 of a mile. So I need to split my number line into 5ths. I need to split it into 5 equal parts. So here I have 1, 2, 3, 4, and then the 5 will be the 1 whole. I need to label them 1/5, 2/5, 3/5, 4/5, and then 1 whole is 5/5. Okay. So now I take a look at my data. So for the 1/5, I have 6 children that rode 1/5 of a mile. So on top of the 1/5, I'm going to mark 6 X's. 1, 2, 3, 4, 5, 6. For 2/5 of a mile, I have 4 children that rode that distance. So I'm going to mark 4 X's. 1, 2, 3, 4. For 3/5 of a mile, I have 2 children. So I'm going to mark 2 X's. For 4/5 of a mile, I have 2 children. So I'm going to mark 2 X's. And then 1 mile, I had 1 child ride that distance, so I'm gonna mark 1 X. So this is a line plot because I created a number line and then I represented the measurement data that's here from the table on the line plot by marking X's to show how many children rode that distance, okay? So now I'm gonna take us to our math book. I have display measurement data in a line plot here. So it says you can represent measurement data for fractions of a unit in a line plot. The line plot's number line will look like a ruler. So here's example 1. The science room has a collection of bugs. Each bug's length is measured to the nearest 1/8 of an inch. Make a line plot to represent the data. So first, the measurement data is shown in the tally chart. So here we've got this tally chart that shows us how many bugs are measured to each eighth of an inch, okay? So it shows that there are none, a 1/8 of an inch, 2 2/8, 1 3/8, 2 4/8, 6 5/8, 5 6/8, and then 4 are 7/8, and 1 is 8/8 of an inch, okay? So the first step is to go ahead and create the number line to represent the value of each bug's length. So they start with 1 and they end with 8/8 or 1 whole because the largest measurement is 8/8. Okay, and then they split the number line into 8 equal parts because the denominator is 8. So they have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8. So down here, it says next place an X above each measurement every time that a value occurred. So we had 0 bugs that were 0, right? We had 0 that were 1/8 of an inch. So there are no X's marked for that measurement. We had 2 bugs that were 2/8, so there are 2 X's. 1 bug was 3/8 of an inch, so there's 1 X. 2 were 4/8 of an inch. We had 6 that were 5/8 of an inch, so there are 6 X's. 5 were 6/8 of an inch, so there are 5 X's. 4 were 7/8 of an inch, so there are 4 X's. And there was 1 bug that was 8/8 of an inch, so there's 1 X marked there, okay? Let's go ahead and move to example 2. So example 2 says, refer to example 1. Find the difference in length between the longest and shortest bug. Okay, so we have to go back to example 1 and we have to look at that data again to see which one was the longest bug and which one was the shortest bug. So let's take a look back at that data. Okay, so the longest bug was 8/8 of an inch. The shortest bug was 2/8 of an inch. So the longest bug was 8/8, the shortest was 2/8. So to find the difference between the longest and shorter bugs, you have to subtract. Remember, difference means subtract. We have to subtract the shortest length from the longest length. So we're going to subtract 8/8 minus 2/8. So that is 8 minus 2, which is 6, and our denominator 8 stays the same. So, and 6/8 is equivalent to 3/4. So the difference between the longest and shortest bugs in the collection is 6/8 of an inch, or you could say 3/4, but you do not have to find the simplest form, okay? All right, let's go ahead and do our guided practice, okay? So it says for exercises 1 and 2, use the tally charts shown. So we're going to use this tally chart called button sizes. So it says the tally chart represents the width of buttons collected by Bella's mother. Represent this data in a line plot. So here it has the button sizes in inches already listed for us on a line plot in eighths because the data is given to us in eighths of an inch. So what we have to do is mark the X's onto the line plot. So I look at our first measurement is 1/8 and I see that there are 6 tally marks. So I'm going to mark 6 X's on the 1/8. 1, 2, 3, 4, 5, 6. Our next measurement is 3/8 and there are 3. So I have to go over to 3/8. So there were none that were 2/8. So I'm skipping 2/8. I'm going to 3/8 and I'm going to mark 3 X's. 1, 2, 3. There is 1 button that was 4/8. There are 2 buttons that are 5/8. So I'm going to mark 2 X's. And then there are 4 buttons that are 7/8 of an inch. So that means we're skipping 6/8 and we're going to 7/8, and I need to mark 4 X's. 1, 2, 3, 4. All right, so now it says, suppose the buttons that were 3/8 inch wide were laid in a row touching. How far would that row extend? So I'm picturing this in my mind, okay? And whenever I'm making a picture in my mind, I find it useful to draw myself a picture. So if I were to make a row of 3 buttons, it would look like that, wouldn't it? Okay, and the reason I drew 3 is because it asked us the buttons that were 3/8 of an inch, and there were 3 buttons that were 3/8 of an inch. So I'm picturing these 3 buttons, and each one of these is 3/8 of an inch. So this is 3/8, here's another 3/8, and here's another 3/8. So what this is asking me is, how far would that row extend? So I need to know what would be the measurement of all of them together. So that would be 3/8 plus 3/8 plus 3/8. So I would add my numerators, 3 plus 3 plus 3. So 3 plus 3 is 6, plus 3 more is 9. And then my denominator 8 stays the same, so it's 9/8. So I could say 9/8 inches, right? Or I know that this is larger than 1, so I could change it to a mixed number. So I can say 9/8. If I make my number line, 8/8 would be 1 whole, right? And then I would need 1 more 8 to make 9/8, because 8 plus 1 is 9. So that 8/8 is 1 whole plus another 1/8 would give me 9/8 inches. Okay? All right, boys and girls. So I hope that you learned how to represent measurement data in a line plot. I want you now to go ahead and complete on your own page 745 to 746. And I will see you for our math lesson tomorrow. I hope you have a fantastic day.